In today's video, we are going to look at the second half of the chapter on the law of cosines. So specifically today, I want to look at the triangles of the form side, angle, side, and solving these using the law of cosines. And then I'm going to look at some word problems that look at the law of cosines. So to do this, I'm going to do an example. So I'm going to use this triangle here that is going to be a side, angle, side triangle. So I've got an angle beta, I'll put beta down here, and beta is going to be 47 degrees. I don't know my side B, but I do know the other two sides. They're going to be 3 and 6. Okay. And I don't know alpha and I don't know gamma. Okay. So like I said before, with the side, angle, side, it means that we know two sides and the angle that lies between them. Okay. Whenever you get a problem like this, the only way to start solving this is by using the law of cosines. What I want you to do whenever you have one of these, the first thing is to go ahead and use the law of cosines to find that remaining side. Okay, so with the side, angle, side, first thing to do, find the remaining side. So I'm going to use the law of cosines in this case that has b squared is equal to a squared plus c squared minus 2ac cosine of beta. Okay, because I know a and c and I know beta. So a is going to be 3, c is 6, then 2 times a times c is going to be 36 cosine of 47 degrees. If you plug all of that into your calculator, you should get 20.44805, and that tells me that if when I square root that, remember we need the positive square root, it's roughly equal to about 4.5. Okay, so I've now got b using my law of cosines. Now the question is, what's alpha and what's beta? And you can go ahead with this and use the law of sines like I said before. But what I actually want you to do, and this also goes for the 3 sides triangles that we looked at in our last video. What I want you to do here is actually go ahead and solve for the largest angle first, and do that using the law of cosines. Then the other one you can find either by using the law of sines or by just subtracting the other angles from 180. But I want you to do this with any law of cosines problem. So whenever using a side, angle, side, or side, side, side triangle, what I want you to do is solve for the largest angle first, and I'll tell you how to find that. Using law of cosines, then the other angles can always be found either, if you have both of them, you can subtract from 180, or you can use the law of sines just to solve any other angles. Why are we doing this? Well, you'll see in a minute when I use this law of cosines in order to solve for my largest angle. If you go back to inverse trig functions, remember that the inverse of cosine was always in quadrant 1 or quadrant 2, meaning that the inverse of cosine will actually give us the correct angle that we want, because there's never going to be an angle in a triangle that's greater than 180 degrees. So it's all of our angles are always going to lie in quadrant 1 or quadrant 2 on the unit circle. So by using cosine inverse, it will actually give me the accurate angle. Okay. Sine inverse, remember, looked at quadrant 1 or quadrant 4 using negative angles if we wanted to go that way. But I always have to check with sine inverse, do I have the correct angle, or can I look in quadrant 2 using the angle that has the same y coordinate? Okay, so what I want you to do for the largest angle that may lie in quadrant 2 is to use that law of cosines, because we know that the inverse of cosine will give us the accurate answer. Then you can go ahead, once I know what that largest angle is, the rest of my angles have to be less than 90 degrees. You're only going to have at most one angle that's greater than 90 degrees in a triangle. So once I have that one largest angle, the other two angles must be acute. So I can therefore go ahead and use inverse sine and get my accurate answer. So I could use the law of sines after I've got my largest angle and not have to worry about whether there's one or two triangles, etc., and whether things actually work out. So whenever you have a side angle side or a side 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 triangle, what I want you to do is just go ahead, use the law of cosines to find the largest angle, and then you can use either, in this case, because once we have the largest angle, there's only one angle remaining, so we can just go ahead and subtract the other two from 180, and we have our answer. If we still need two angles, I can then go ahead, like we did in our last example on the last video, and use the law of sines to solve for another angle, and then subtract the two angles from 180 degrees. Okay, where is the largest angle? The largest angle is always opposite the longest side. Okay, in this case, my longest side is 6, telling me that gamma is going to be my largest angle. So I'm going to go ahead, use law of cosines to solve for gamma. Then I can just go ahead and subtract the two angles, 47 degrees and whatever gamma is, from 180 to find alpha. Okay, so your largest angle is always opposite your longest side, and we're always going to solve for that using law of cosines. Then we can solve any other angles using law of sines or just subtracting from 180. Okay, so using a law of cosines, okay, and I'm trying to solve for gamma, so I'm going to use the formula that I know uses gamma, which is this one here. And I'm going to plug in A, B, and C into this and then solve for gamma. So I'm going to have 6 squared is equal to 3 squared plus 4.5 squared minus 2 times 3 times 4.5, which will give me 27 cosine of gamma. You then rearrange for cosine gamma, and you should find cosine gamma is going to equal negative 0.241486. And by doing cosine inverse of that value on your calculator, you get 104 degrees. Okay. So now I've got that angle, and I know that that is my largest angle. So all I have to do now is go ahead and solve for alpha. So I take 180 degrees and I subtract the other two angles off of it. So I now have alpha, beta, gamma, and all three sides. Okay. So whenever you have one of these problems, I want you to just go ahead, solve for the side that you don't yet know. So we've solved for B. Then I've seen, okay, which one's my longest side? Find the angle that is opposite to the longest side using the law of cosines, because that's going to be our largest angle. Once I've got my largest angle, in this case with side angle side, that will give me two angles. I can just find my third one using the law of sine, subtracting from 180 degrees. Otherwise, you can use the law of sines to solve for additional angles if you have to. The last thing I want to do is to go through a word problem. These are kind of tricky just because of the wording of them, so I do want to go over this just in case you ever see it. But it does use the law of cosines. So in this example, we have that a helicopter takes off from WRAL studios, so TV studios, and travels north 70 degrees east. This is the thing that I want to talk about, at a speed of 90 miles per hour for 30 minutes. The helicopter makes the course change and then travels north 25 degrees west at a speed of 80 miles per hour for 15 minutes, and then lands. Determine the distance between the WRAL studio and the helicopter to the nearest tenth of a mile. So I am looking for what's the difference from where we took off here to where the helicopter landed here. So I want this distance here. Okay. What I really want to talk about are these two things here. Okay. We've got north 70 degrees east. That tells me that I am traveling at 70 degrees east of due north. Okay, so due north is here, and I've gone 70 degrees east of that. So I measure out 70 degrees to the right, okay, which is what this is here. So this angle here is 70 degrees, okay? And then same with my next one. I've got north 25 degrees west. That means I'm traveling 25 degrees to the west of due north, telling me that this angle here is going to be 25 degrees. Hence why we have 65 degrees here, okay, because we know that that's going to be a right angle between north and west. So whenever you get something like this, so let's say you had south 60 degrees east, that means I would be traveling 60 degrees to the east of due south. So that angle there would be 60 degrees. Okay, so whenever you get one of these, you are traveling to that angle to the east or west of due north or due south. Okay. So in this example here, we've got all of these measurements. Because I know that that angle was 70 degrees, that tells me that this line here is going to be 20 degrees off of here, okay? Hence why we know that this angle here is 20 degrees, because it would be a Z angle, so the opposite angles must match. So because I've got that, that tells me that the full angle here must be 95 degrees. Okay, so I know it looks like a right angle is just off of a right angle. It's actually a full 95 degrees is what we have there, and that is due to those opposite angles. And then we know that we've got 65 degrees between that line and due west, and I've got 20 degrees furthermore to go because of that opposite angle. So that full angle there is 90 degrees for that triangle. And then how do I get my distances? Well, I know that I've gone a speed of 90 miles per hour for 30 minutes. So if I'm doing 90 miles per hour for 30 minutes, okay, I could do 90 miles in a full hour, but I'm only traveling for half of an hour, meaning I must have traveled 45 miles. Okay, if I've done 90 miles per hour for half of an hour, I've done 45 miles. Okay. Similarly, I've got a helicopter that then changes course, and it goes at a speed of 80 miles per hour for 15 minutes. So in a full hour, I would have gone 80 miles, but I'm looking at 1/4 of an hour. So a quarter of 80 would be 20. So I know I've gone 45 miles and then 20 miles. That's how I've got those two distances. So I now have one angle in my triangle, and I have two sides of my triangle that lie either side of the angle. So the angle is in the middle of the two sides. So I know I can go ahead and use the law of cosines because I have a side angle side triangle. Okay. So to find this distance here, okay, I'll call it d squared, okay, is going to equal each of the other sides squared minus 2 times each of the sides, which is going to give me 2 times 20 times 45 multiplied by cosine of this angle that is between them, which is 95 degrees. When you work that out, you should get roughly 2,409.312 roughly, and then we can just square root that to find d. So d is going to be roughly 49.1 miles. Okay, so that's why I wanted to go through this problem. So I wanted to make sure that you understood these directions, how they've quoted them here, and also to find those distances. Okay, so whenever you get a problem like this, you figure out what the angles are just as they've done here. You may have to do something like this where they found the opposite angle to get that full angle in the triangle. And then you can go ahead, figure out your distances, and then you can go ahead and solve using the law of cosines. I know that these aren't exactly easy problems. There is another problem that you can look at that is very similar to this on page 518 of the textbook. And you can see exactly how they've done this again, just with a different triangle.